Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called, excuse me, frog in the throat, Entropic Islands by Jonesy, and here are the rules. Hello, buongiorno. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Digits are grouped into entropic sets. We have low, which is 1, 2, and 3. We have middle, which are 4, 5, and 6. And we have high, which are 7, 8, and 9. A digit placed in a circle indicates the size of the orthogonally connected group of cells that all contain digits from the same entropic set as that digit. No group contains more than one circled cell, and not all groups contain a circle. So what is an orthogonally connected group of cells, or as I like to call them, orthogonally connected regions? Or we could say orthogonally connected groups. Well, that means to go from any cell in that group to any other cell in that group, you have to be able to go through edges all while staying within that group, or region as I like to call it. So this is an example. So if these were all the same entropic set, this would work because these would all, to get from any cell in that group to any other cell in the group, you can just go through edges while staying within that group. This, however, would not be an orthogonally connected group because these two cells, while they can get to each other by going through edges while staying within the region, they can't get to the other cells in the group just by going through edges. They have to go through a corner, or they can go through an edge, but they have to exit the grouping, which is not allowed for orthogonally connected groups of cells. And again, no group contains more than one circled cell. Not all groups contain a circle. Digits separated by a white dot must be consecutive, and digits separated by a black dot have a 2-to-1 ratio. So, for example, if this was a 6 here, this would have to be 5 or 7 to make sure that these digits are consecutive. If this were a 2 here, this would have to be 1 or 4 to maintain a 1-to-2 ratio because there's a black dot between them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, let's start by marking where there are group boundaries. So there's going to be a group boundary between any two circles that share an edge. Because, well, they are going to be that. Therefore, this is in its own group. It only has a group of size 1. So this must be 1. So this is a low group. This must go out because it can't be size 1. And so this must be the same grouping here. This has to be a different grouping because it's a different set. This is a different set because you can't have more than 2 circles in the same set. So this is a different grouping here. This is another grouping here, but it could just be that way. So this is grouping there. However, if this were done here, the problem is these would also be low entropic sets. So this can't be done here. This has to continue on. Same with this. If this were 2 here, then these would also all be low, which would be part of this 1 entropic set here. So this has to be all dark. These have to be greater than 3. So this is not part of this circle here, and it can't be part of this circle here. So this must be at greater than 3. So this is a set. That means orange has to go this way, because again, it can't be 1 because of 1 in the box. This has to go down here, because it cannot be size 1. So this is at least size 4. This can't be size 1, but we don't know which way it goes. This could actually be a 2. That's perfectly fine. So these are all the same entropic set. So again, pink has to get out here. And we know that these digits are one entropic set. These are the other entropic set. So this can't be either of these entropic sets. And one of them must be mid, and one of them has to be high, which means these all have to be low. So this is 2 and 3 as a pair. We have 3 pink cells in this box, so this can't be pink. It must be dark entropic set. So this is 2 or 3 that way. These have to be 4 through whatever. And this, we only have these. It cannot go more than 3 in a row, or 3 in a column, or 3 in a box. So no matter which way this goes, if it goes to the highest extent, it has to go, it would be 5 at most here this way, 5 at most that way. Because it can't go here because we already have 3 digits in the same box. And there are, in each set, you can only have 3 per row and 3 per box, or 3 and 3 per column at most. So this can't go 4 down there, it can't go 4 across here, it can't go 4 across here. So this is guaranteed to be a middle digit, which means these are high digits. So this is high digits, this is a middle digit. So middle has to continue here. That's only 3, and it can't go any further this way because we can only have a limit of 3 per set here. So then green has to go this way. That's a total of 3 there in the box, so that's done as a set here, which means this is size 4. So this cannot be size 4, it can be size 5 at most though, so this is size 5, and we don't know whether it goes this way or whether it goes this way. Red has to continue on this way, because it has to be 7, 8, or 9. That leaves this as a 6, this as a 4, and it could go pink, green, green, or green, green this way. We don't know which one. If red goes this way, that's all the reds we can have in this box. But you cannot go red this way if that's the case. So you're guaranteed red has to go. So we have to have 7 digits in this orthogonally connected group. I forgot about just saying what this is. Oh, okay. Hopefully it was clear. So if we try to go 3 this way, a high digit cannot be in a 1 to 2 ratio with another high digit. Right? 7 cannot be in a 1 to 2 ratio with 8 or 9, and same with 8 and 9 with 7 or 8. So no matter what, to have 7 digits here, we have to go this way. And this is a border here. So we could go to either one of these two. We don't know. We could also go that way. We don't have to go that way. Remaining digits in row 1. We have 2, 3, 7, 8, and 9. We know the other middle digit has to be one of these. So the remaining digits in this box all cannot be middle. They all have to be low or high. Okay. Remaining digits of row 4 have to be low or middle. These are 7, 8, and 9. Remaining digits in column 1 are low and high. Remaining digits in column 2 are low and middle. This can't be middle, though, because we have 3 middles in that box. Okay. Can this be high? The answer to that is no. Because if it were high, these can't be 4 because of 4 in the column. So where's 4 in this box? It has to be here. Again, this can't be high. To be high, it would have to connect with at least 6 other high digits, but none of these can be high. None of these can be high, so it can't be there. So then this has to be a low digit. That means this can't be low here because these have to be different or entropic sets. You cannot, so we have all the mediums in column 2. That means medium has to go that way. These have to be different entropic sets. So then we have to have medium go that way. That's 3 already in this box, so then medium has to exit out. It has to be 6 too. So that means, and then we have 3 mediums already in column 4. So this is done that way. This is done here and here. So medium has to continue on. This has to continue on this way. This has to continue on that way. And so this is done as a region. This must be consecutive with a different set. So this must be high here. Because we don't have 4 available, and 4 would be consecutive with the low digit. So this must be 6, this is 5, this is 7. So no 7 here. These can't be 7 because of 7 in the box. Okay. So we have to have 2 or 3 here. These are 3 lows in this box 7, so these cannot have a more low. So this is high, this is high. So this must be low here and then low here. Because this has to be size at least 2. That makes that 3. So this is 3, that's 2, because this is a size 3 region at least. So this must be a high digit here, which means this has to be low here. Low is never going to be in a 1 to 2 ratio with a high digit. So this high digit cannot continue out this way. It has to continue here. And then this is done as a region because these have to be different regions or different sets because otherwise we'd have 2 circles in this set. So this is low. If this were high, the problem with this being high is we'd have 3 highs already in the box, so this couldn't be high, and this would be an entropic set of just 1. So this cannot be high, it's low. Low has to continue out here. We have 3 lows in this box too, so this can't be low, it's high. This is the remaining digits that are low here, because we have 3 lows, so the rest of the digits must all be high. So then this is an entropic island of size 2. So that's 3. This is 1, because that's the only remaining low in the box. So that's done. So this cannot be blue. It's green. This can't be blue. We have 3 reds in row 2. So this cannot be red. They are low or medium. This is not 2 or 3. It's 7, 8, and 9. This set, this can't be high here. So this is done as a set. Same with this. Same with this. 1, 2, 3, 4, 5, 6, 7, 8 cells. Well, also it was a 1 to 2 ratio, so we knew it had to be 4 and 8 there anyways. So this is 9, this is 7, no 7 or 9 here, it's 8. So these are 7, 9 as a pair. This red has to go here. So this is red. This can't be red or green because they are not the same entropic set. So this is blue here. This can't be red because of the 1 to 2 ratio. So that means red has to continue on going this way. That's 3 reds in box 5, so red has to continue going this way. Then to here. That's 5 only. Can't go back up. It has to go, can't go to the circle here. So it has to go down. That's 3 digits already in box 8 as high. So this cannot go down. It has to continue this way. That's 1, 2, 3, 4, 5, 6, 7 now. So that could be done as a region. We don't know. So this is here. We have to have 6 digits in the middle. So this must be middle. That's 3 middles in box 8. So this cannot be any more middles or highs. So these are both low. This is size 1 as a region. This cannot, this is 1, which is in a 1 to 2 ratio only with 2. So this is low there also. This is 5 and 6 as a pair. We have 4, 5, and 6 there. These can't be, so this can't be high because we have 3 highs in that box. So this must, it can't be low because these are different entropic sets. So this must be medium here. And it's 4, 5, it can't be 4, it's 5 or 6. This entropic set has only 3 mids can be part of this set in this box. So this has to go out somewhere here. And it cannot, we already have a middle there, and one of these 3 is mid. This can't be part of that mid to go out because every entropic group, connected group, has 1 single circle. So this is not mid. That's low. One of these must be mid, which means this we have 3 mids in row 4. So this can't be mid. This is low. So this is a different region, different grouping. The rest of these are low or mid. We cannot have, so we can only have 1 mid here, which means we are guaranteed a low here also. Because we can't have 2 mids here. So we have guaranteed low here, which means, sorry, we have 3 guaranteed lows in column 6, so these cannot be low. These are mid. We have 3 guaranteed mids in box 5, so this can't be mid, that's low. That means the remaining digits in box, in row 5 have to be all high. So this, if it has 3 mids here, and it connects here, that's only 4 mids, because that's already 3 mids in row 4. That would have to be low, and this would be connected to 4. So this cannot be the mid that we're connected to. This must be low. No low here. This must be mid. And so this is 1, 2, 3, 4, 5 already connected. One of these two is guaranteed to be a low. So it's going to be connected to this low set here. So this must be 3 here. So this is a low mid pair here. These can't be high, so this is low or mid here. Ooh, that's interesting. We have in row 8, 3 highs and 3 mids, so the rest are low. So this is a boundary here. 6, 7. We have 3 lows already in. We have 3 lows in row 9. We also have 2 highs in row 9. So if we tried to make this 9, 1, 2, 3, 4, 5, 6, 7, it can't go here because that's a circle. So it'd have to go here, but then we can't extend another one because that would be 4 highs in row 9. So then this must be 7. This is size 7, that's 9. This is done then. We also have 3 highs in column 9 already. So this digit cannot be high because of the 3 highs in the and this shares edge with highs already. This can't be high. It can't be low. This has to be middle. We have 3 middles in column 7, which eliminates middle in the rest of the column. So no mid, no mid. These are all then low. We have 3 lows in row 7. These can't be low. So this is a high 5 or a high mid pair. We also have all the remaining digits here. This has to be 2. So this is low and low. We have no more lows here. So that's mid and mid. This can't be 3 or 2, so this is 1, which makes this 3 there. That leaves that as 2, which makes this 1. That's 3. 3 here eliminates 3 here, so that's 2 and 3. That's size 3. 2 cannot be here because of 2 in the column, so 2 has to be here, which is the low, or yeah, a low digit. That's 3 lows in row 3, so this can't be low, it's middle. That's 1, 2, 3, 4, 5, 6. We cannot have this connected to another middle because then it would be already size 7, which is not a mid digit. So this can't be mid, that's low, which means this can't be low, that's mid. Okay, this is boundary here. This has to be a red-green pair. This has to be middle within a 1 to 2 ratio with a high, so that's guaranteed to be 4 and 8. This is size 6, so that makes this 5 here. That's 4 there. This has to be 1. This can't be 1 or 2. It's 3. This can't be 2 or 3. It's 1. This can't be 3 or 1. It's 2, which makes this 3, which makes that 1, which makes that a 2. That makes that a 3 there. From just normal Sudoku. This can't be 4 or 6, so this must be 5, which makes this a 4 here. 5 eliminates 5 here, so it's 6 and 5. This can't be 5 or 6, it's 4. This can't be 4 or 5 because 4 and 5 in the row. So that's 6, which makes that a 5. 4, 5 eliminate 4, 5 here, so that's 6. This must be a 4, 5 pair here. This is 4, 5 as a pair. Remaining digits in column 1 are 7 and 9. That leaves this as an 8 here. This must be 7 here because of the 8 and 9 in the row there. This can't be 7 or 8, it's 9. This can't be 7 or 9, it's 8, which leaves this as a 9 there. No 7 or 9 here, so that's 8, which makes this a 9 there. This is 7, 8 as a pair here. 7, 9 as a pair here, no 8 there. This has to be 6 because of 4 and 5 in the row. We don't know about this. So we have to have 4 and 5 remaining here. Let's check the areas. So this is definitely 1 size 2, 5, 2, 1, 3. Let's draw the boundaries here. 1, 2, 3, 4, 5, 6. This is size 4, size 3, size 6, size 1, size 7, size 2. And so all the circles are valid. We have 7, 8, and 9 here. Remaining digits in row 7 are 4, 5, 7, and 8. This cannot be 4, 5, or 8 because of 4, 5, 8 in the row, so this must be high and is a 7. That makes this 8, which makes that 7 there. That eliminates 7 here, so it's 9 and 7 there. This can't be 7 or 9, it's 8. 7 eliminates 7 here, so that's 9. There's no more highs in column 8 because we have 3 of them, so this must be medium. We have 3 mediums in row 9. This can't be medium, that's high. We have 3 highs in box 9, so this can't be high, it's medium. That leaves this as a 6. 4 eliminates 4 here, so it's 5 and 4, which eliminates 4 here, so it's 5 and 4. That forces this to be 5, this to be 9. 9 eliminates 9 here, so it's 7 and 9, which eliminates 8 and 9 here. That's 7, which makes that an 8. And that's a solution. Yeah, I should have done more for explaining the circles rule sets. Apologies for that. I just went on from that because I was explaining orthogonally connected groups, but I did not talk about the circles having to be the size of that group. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.